answers. Otherwise, please feel free to absolutely contact me on the LinkedIn page of the conference, or find me on LinkedIn directly, and reach out if there's anything you'd like to ask or discuss or raise as points at any time. So I want to kind of pick it up from a point where, you know, I'm going to make two assumptions for the purpose of this 45-minute presentations for a second. I think many of you will agree with what I'm about to say, and I hope you do. And I think they're beginning to be generally accepted by the industry at large at a very broad level. The first thing is that data and AI is going to be, many analysts are saying this, in the medium term, larger than enterprise software in terms of total market size, which is just a foundation on which I think we need to frame the context of everything that we're learning about data and AI, and what the opportunity of data and AI is, and what some of the challenges are, so that we understand how important it is. So it's a huge revolutionary aspect to the market that we're witnessing. And the second thing is, as with all of these revolutions in IT over time, has shown time and time again, this entire industry, so you as practitioners, you as vendor, you as integrator, or partner to this industry, are on a journey towards a platform. In the long run, in the short run, whatever the time frame is going to be, but this data and AI capability at large is going to be provided by a platform capability of some sort, because every significant evolution of innovation in the IT space has always gone from best of breed in certain niches, and then eventually to a platform. So it's going to be very large, and we're on a journey towards a platform. And I think it's about the ambition, the digital ambition of businesses everywhere, in businesses in all verticals, to drive digitalization into the agenda and really capture value from data assets. And I think the key kind of senior management perspective on that is really interesting to bear in mind, and kind of broaden in on at all times. The expectation of value around data and AI is to generate real measurable ROI on the investments made on data and AI. So there needs to be a return on investment. Secondly, there is an expectation that time to market, time to value is reduced, that the benefits from data and AI as a capability for transformation towards the digital agenda of the business is something that is reduced on the time axis as much as possible. And thirdly, there needs to be, you know, a strategic vision and an execution of tactics towards that vision, that data monetization that's inherent to the digital agenda of any business is actually turned into a reality. And when we're confronted with that expectation from the business, you know, at the advent of a revolution towards data and AI, even becoming larger than all of enterprise software, then I think there are kind of three areas that we need to look at that are really important for CDOs, heads of data engineering, heads of data science, and the functions that serve the business. And that is, you know, there is just an incredible breadth of requirements in terms of the types of workloads that include, you know, traditional SQL, looking at the data, what happened historically, but also, you know, with business intelligence, obviously, but also AI and machine learning workloads for the future. So we have to enable ourselves to capture value and becoming more industrialized in the production of different types of data and AI workloads across all dimensions of data and AI, which is really important. There needs to be a reduction of risk. It's a complicated architecture that we're referring to when we're thinking about all of data and AI. There is a lot of data. There is a lot of integration vectors, and as a consequence of the amount of data, there's a huge attack vector generally. So we need to make sure, even for just internal governance aspects and to drive data quality, but we need to make sure broadly that the risk across all of those dimensions is reduced by really having a really singularly consistent way to store, process, manage, and secure data. And if anything, I think this idea of governance, quality, and security is one of the main drivers towards this notion that we are all traveling on a virtual journey towards a platform with data and AI. And of course, with all that, it needs to be constrained in terms of cost. It needs to, it's the point that I made a moment ago, first on the list. We need to have a demonstrable ROI, a return on investment, that actually shows that the investment in data and AI is actually not only worth it, but actually is maybe has some growth pattern to it, or maybe even exponential growth, so that we can see that that the investment in data and AI is yielding all the upside benefits, but it's not producing a lot more costs. So these three areas are really the kind of, not the founding principles of Databricks as a company, but these are the things that Databricks, with our services and the platform we provide in the cloud, that we concentrate on in order to make data and AI a reality. And what we're seeing now, of course, is that this is relevant for all verticals, for all industries, in all shapes and sizes, whether these are the small digital natives that are kind of attacking a high value business model of maybe one of the incumbents with a highly digitalized, highly dynamic data-driven model, or whether it's some of the larger incumbent multinational organizations that are absolutely putting data at the center of their ability to take decisions, make decisions meaningful, but also understand on how desired outcomes can be turned into a reality. That whole vision of data and AI is accelerating. And if you're looking at the way that these organizations are functioning, in the way they think about this, is that they are truly industrializing the outcome of business cases and business use cases based on data and AI, and are looking for the infrastructure and the applications and the services that can make that a reality. In fact, I added this slide in listening to some of these the presentations over the last day and a half. I think it's very interesting that we can double click and drill down into the challenges that we have there. And it's interesting. This particular slide focuses on machine learning as one aspect, but each and every individual aspect of the sum of data and AI is just a part of that. The sum of the challenges is actually much larger and can be best aggregated as maybe being configured as data in order to provide data quality of huge amounts of data in velocity and volume to the right people at the right time for the right use case. So it's another reality that has been like a red thread throughout the presentations I've heard, where people have talked about dependencies that they have. People have talked about limitations that they're facing, even though they're doing particularly well with their particular approach in one area. The bigger picture is just that, the bigger picture, and underlines again this idea that the platform is going to be the future. And where do these problems really come from? Right? It's all about architecture. It's architecture over time, historic time, in that typically organizations have 4 different stacks to handle all of the data workloads, and these are all different. They're all individually different and serve individually a different purpose, and have been architected with the best intentions in mind, with the best technology that was available at the time, in order to serve that process, serve that purpose, which of course is extremely valuable, and achieve just that. In order to, over time, expand on that capability of those different architectures, you have this whole incredible, endless list of tools to support each one of those. There's just a whole different slew of open source tools that need to be connected, where DevOps needs to be involved, where security needs to be assured, where integration vectors need to be managed. And we're also dealing with the fact that inside of each of those architectural silos, effectively, there are proprietary data formats. So if you want to kind of think about that being the reality, then and you're kind of drawing on the sum of all data, and you're drawing on all of the data assets that are available to you, moving that data as indicated by those red dotted lines, moving that data across those stacks is extremely resource intensive, and of course it's also extremely expensive. And the other effect, of course, is that each one of these silos effectively have siloed the teams as well, organizationally. So there are different organizational, these may be different in terms of organization, in terms of, even geography, in terms of, global spread. The communication between these teams is hindering the speed with which the value can be extracted from the sum of all data. And what happens, of course, is they concentrate on a job that they have, quite naturally, and of course they do a stellar job, but it further entrenches the siloed nature of the data itself. So therefore, really creating a further kind of like a walled off world of a lack of consistency in terms of governance and data quality models and the openness of the systems that are available, and making everybody, as a consequence, extremely unproductive. So this is the reality that we have today. So the business is asking for the industrialization of outcomes and use cases. We're struggling with interdependencies from different elements of managing that data, and we have a history to deal with that is effectively siloed, proprietary, and very difficult to integrate across and aggregate across. So if you then go to the leadership and ask, what is it that we should be considering doing, and if you had a magic wand, what would you do to solve that problem? The conversation invariably turns towards incredible growth of data and the growth of the opportunity of capturing further data, such as click streams and video and speech, and the whole realm of customer data from transactional systems and emails and web pages and all of those things that we deal with every day. So knowing that we have these challenges in these organizational and architectural and technical silos, knowing that the business is driving this value expectation, and if I had a magic wand, then I would be looking for, as much as possible, open standards and open formats in order to deal with what I have today, in order to overcome what I have today in terms of limitation and challenges, but also to deal with the expectation of the incredible challenges that are yet to come with the explosive growth of additional data. Okay, so if you were to kind of go to the drawing board and say, what would a platform look like as we journey towards this platform, and if we concentrate on this idea of open standards and open formats, there's going to be some pretty important questions that we need to ask ourselves, right? The idea of open formats and open standards immediately says, okay, the reality is that I don't have a magic wand, and if we're at the drawing board, what is the cost of portability? How do I maintain what I have today as the baseline standard that I've been providing to the business, and port to a new world that same standard of capability, maybe making things easier, breaking through some of those challenges, but is that going to be cost effective? Is it even viable to pursue a strategy, or do we need to make the pain, wait for the pain to become so unbearable that you know, we are going to have to make a strategic, very, very expensive decision to start such a portability. You know, what does the ecosystem look like? Is it a, you know, whatever I move to is going to be, given that we're all constrained by skilled resources being available in the market, you know, what is the ecosystem in terms of, are there people that can actually deal with and handle and operate this technology? Bringing people online with this approach, what's the learning curve like? Can it be democratized? Can it be, and can large teams, it's probably worth turning off my phone, apologize. Can large teams be enabled to learn this technology very quickly? And you know, what we're seeing with across all of our customers is, as time goes by and we entrench ourselves into the status quo and we accelerate, you know, the best of breed approach for individual aspects of the data and AI spectrum, and we further drill into that, what we're really doing is we're actually creating a trap for ourselves, because the notion of platform becomes more expensive the more entrenched we become. Another huge aspect is, as we're still at the drawing board, is we have to be multi-cloud. And multi-cloud is a fascinating conversation. It's a huge factor of cost control. Having multiple cloud providers is a strategic imperative for many, but it's also the product of acquisition and mergers, for example. It also, you know, raises the whole question of data gravity. If I'm operating transactionally or otherwise on different clouds, how does the data gravity between, you know, something that I want to be universally available for data and AI industrialization, how is it going to be possible for us to be able to incorporate these different clouds without transferring the data between clouds, incurring huge I/O costs? So there's a whole world of multi-cloud questions that are so incredibly important, because over time, and by time I don't mean a long time, because this journey has already started, organizations are becoming multi-cloud. And of course, you know, is there a shortcut that we can take further? You know, is there going to be you know, an engineering dilemma in that we're building ourselves kind of into, or we're kind of designing ourselves into a corner where, you know, we're beholden to the engineers driving an outcome in terms of kind of like this endless engineering waterfall approach, or is there a more homeopathic, agile, MVP-based approach that we can use to control risk and manage cost in the migration to such a platform? So, you know, if these are all variables that people are thinking about in terms of where the data and AI journey is going to bring us, then we need to ask ourselves, well, what will this data and AI architecture, what is it going to look like for most enterprises? And I think we need to just take one step back and look at the data warehouse and look at the data lake, because these are the two starting points that we've got. We have on one hand data lakes, and you know, they're obviously fantastic at supporting machine learning. They have open formats, so that's a tick in the box. They are very capable of handling high volumes of big data, and there's a big ecosystem to support that. So, you know, there is a huge set of advantages in the data lake. However, there is a particularly significant drawback in that they have no or very little support or capability to allow business intelligence to operate on them. So the whole notion of the complexity and the management overhead of managing data quality is the limitation that drives this inability to provide business intelligence and SQL type outcomes, which which is the core of data and AI, and one of the most important sets of workloads to be able to be handled, right? So data lakes are great in one way, but they have certain limitations. And on the other hand, the data warehouse also has some super advantages in being really well understood, and of course been around forever, and they support business intelligence excellently. But of course they don't support in any way, shape or form, or can viably support a at scale capability for machine learning workloads. And also, of course, data warehousing is inherently proprietary, and the outcomes are limited to an SQL interface. So it's these are two starting points that are important to consider and to think about in terms of their advantages, and be aware of some of the disadvantages as well. Databricks has coined the phrase Lakehouse and is being picked up by the industry, which we're very proud of and very pleased with, because it actually does describe really well the future architecture of what it is that organizations will be striving for and will be basing data and AI as a reality. So Lakehouse isn't unique to Databricks, but as a pattern in terms of as a model of an architecture, it's the best definition that we have right now of describing what this future architecture will look like. It'll be a singular platform. It'll be a singular platform with the ability to really incorporate a very open, completely standard data storage format. It will provide all of the data governance required for all data sources that are industrialized for scale, for onboarding, is able to deal with real-time data and with unstructured data of any type, shape, or form, and will enable in that platform, in that open architecture, to leverage that singular place of data storage based on that universal governance, with those open standards to perform AI and ML type workloads, but also business intelligence and SQL. So really bringing the data warehouse and the data lake with both of their advantages together into one paradigm, and eliminating the traditional advantages that the data warehouse has and the data lake has. So that really is at a very high level what Databricks does. We believe and we see that data engineering and data science and data and AI as a concept is something that we need to focus on individually. So what we do is we provide this service, this platform as a service through our cloud partners, whether it be AWS or GCP or Microsoft, and we concentrate on really serving all of the constituents of the data and AI world, individually and collectively. We believe, and we're seeing this with our customers, and there's almost 7,000 of them now, that this is one of the most important side effects. The bringing together these different functions that have traditionally been siloed off and have been lacking in communication together into one area, one work area of collaborating together on the same platform based on that same open standards format based storage capability in the same environment, has incredible productivity gains and incredibly has amazing time to value benefits. And so in many ways, what we do and the way that we start with the journey with our customers is that we actually don't, implement a platform. We work with data engineers and we work with data scientists. I like to give you an impression of each. So with a data engineer, for example, we work with the help of our open source format Delta Lake to drive industrial scale data onboarding through this 3-stage model of delta tables in order to derive, even with unstructured data and mass data, a level of data quality that then becomes the centrally available repurposable data set that can be used for SQL workloads or AI and ML workloads. It massively simplifies the whole question of data engineering, and because of various optimization and performance results that we're able to talk about in detail, the efficiency with which we perform this effectively ETL process is such that the cost reduction in using Delta in a Delta Lake as the basis to the Lakehouse foundation of Databricks is incredibly high. So it's extremely cost effective, extremely productive, and a great purpose for engaging with Databricks on its own. So that's data engineering. And with some customers, maybe we concentrate more on data science, where where the Delta tables are universally available in order to drive within a collaborative notebook environment with integration vectors to all of the open source notebooks that people want to use, with native integration to all of the capabilities in Delta itself, the data science outcome and the productivity for creating those workloads. Same for machine learning, including the entire notion of model registry, reproducibility, prioritization, but also documentation, creating a machine learning store effectively of artifacts that can be repurposed, and brings together the whole process of the machine learning process itself onto the Delta Lake, which is leveraging data that could be used exactly for those AI outcomes, or for example SQL, which is again connecting to the same data set, and it produces fantastic performance with integration to all of the BI tools, and also with a native SQL interface as well, so that the SQL workloads from that same singular pattern of the platform can be purposed. So it's really a journey that customers come on, which sometimes focuses more on data engineering, sometimes focuses more on data science, sometimes focuses more on SQL workloads, but with each individual workload or performance improvement or migration of data and analytics type technologies into the cloud using Databricks, we are beginning to really shape out the platform for our customers. And because of the open standards and open formats, we're not limiting the customer in any to repurpose that data for any purpose, and we're also not limiting the customer in any way, shape, or form in maybe actually using their existing analytics technologies because of the open standards enabling the integration of all of that. Okay, so that is effectively a quick overview of the vision and the reality of Databricks with its Lakehouse pattern of how we enable the industrialization of data and AI platform build, but also use case outcomes. And what we're seeing is phenomenal business value that we are working with our customers to continuously monitor and see what the impact is. So we have it always comes in 3 dimensions. The idea of the platform of data and AI being a journey means that it's important to take the advantages of the cloud with the agility the flexibility of moving to the cloud very seriously, and really not biting off more than we can chew, and concentrating on the kind of outcomes that we're looking for, each regarding to the use cases or the architectural considerations that need to be done. And we're observing that the infrastructure cost reduction that is required because of the high level of efficiency that Databricks is able to provide, and with the incredibly intelligent provisioning capabilities that Databricks as a service provides, means that the savings potential of just the infrastructure layer in a direct comparison in terms of TCO is extremely significant, and in many ways often fuels the process of actually engaging on a project and starting an implementation. The measurement of productivity in line with what the business is requesting and requiring is the second dimension that we concentrate on, and it's the time to value and time to market for data and AI is a core business request, and we're seeing that the productivity gains of breaking through those organizational silos, but all of those, but also those application silos, and having people work together by leveraging the Delta-based Delta Lake single source of data is just mind-blowing. The example I mentioned earlier, or I had referenced earlier in my customer slide, when I was ABN, for example, since starting have implemented over 100 AI and ML enabled use cases within the space of approximately a year of being a customer. So it's an incredible set of gain to really drive those outcomes and turn the data and AI expectation of the business into a reality and start to capture that actual value benefit. And then, of course, the use cases themselves, with the acceleration of business use cases and the incredible impact that data and AI has on being able to become predictive, to have those data-enabled insights, and driving an understanding in the business towards the awareness of data as being an enabler to understand how to get to outcomes, of course, is the reason why data and AI will be larger than enterprise software, and effectively, of course, is a huge accelerator. So the more cost-effective the implementation of the platform, the more productive the teams to industrialize those outcomes, of course, the more valuable the impact is going to be in terms of value by those use cases on the business itself. So that is something that we're seeing across all industries. The Lakehouse is being adopted all walks of size of organization globally, and we're seeing incredible advances in terms of performance and outcomes for data and AI. And we're looking forward to working with you. Looking forward to working with you on seeing how we can help there at your organization. As I say, please reach out over LinkedIn, over the platform, through the conference, and let me know how I can be of assistance. And let's go to some Q&A.
Thanks a lot. Thank you, Frank, for this amazing presentation, insightful. And I would like to have more interactivity now. I gave microphone to Simon from Mantrack. Go ahead, Simon, please.
Hello. Yeah. Could you give us an example about what it takes to build such a lakehouse? How many people, how they should be situated inside the organization, depending, of course, of the size of the company and the kind of stuff the company does.
Okay, so that's I'm getting some alerts here. Can you still hear me? Simon, can you hear me?
Yes.
Okay.
Yes.
Great. Yeah, so that's a great question. I think that what we are typically seeing is that there is a nucleus of a team, often centered on data engineering, to establish the capability that is the Lakehouse, right? So specifically for your question, it's difficult to answer, but bear in mind that Databricks comes as effectively as a service that's being provided native to the cloud provider, that you can assemble, spin up by a click in your Azure or AWS portal, right? When that capability comes alive, of course, it now becomes a question of building out those pipelines in order to manage the process of getting the data into Delta and moving through the bronze, silver, and gold table to be of a quality that you need. So that we have playbooks for that. And we help with our services, and of course we have incredible growth of a partner community to help with that. So there is an organizational requirement with a nucleus of data engineering to enable that. That can be supported by partners, but the operation of the platform, which is why I'm kind of finding it difficult to be specific. The operation of the platform, of course, being a platform that's provided as a service, is all but eliminated. So therefore, the people that are involved in building, maintaining the Lakehouse are actually the practitioners that enable the data engineering and the data science or SQL workloads, rather than actually operating the platform, if that's helpful.
So the benefits is on the usage side. The benefit is there for the people who use it, but in the short term, you don't, of course, in short term, you never save money and time, but it's not that you need fewer people to maintain such a data lake, such a lakehouse compared to other approaches.
No, in fact, on the contrary, it does become more effective. It does come because it becomes more productive. So the operation of the platform is one thing, right? So that kind of disappears. I think that makes perfect sense. The ability in order to the measure of value that we provide and that we investigate and also sense with our customers is where the productivity of the ability to be able to extract and load the data becomes industrializable, because that process becomes more productive. So therefore, any given person that had previously, or with any other approach, if I use your phrase, the people that with any other approach would be burdened by the comparable in-productivity of that process on Databricks would be made much more productive. So therefore, you need less for more outcome, absolutely. So that there are productivity gains. The cost benefits are convergent also, of course, with a move of, for example, a migration from a data warehouse to the cloud, right? And then deciding what the cost effectiveness is of the cloud, right? But then there are other alternative approaches to replacing your on-premise data warehouse, your on-premise data lake in the cloud. So our thesis and what we're seeing is that the optimized Spark capabilities of Databricks actually provide this cost analysis in the cloud, where for any given workload, typically we find that compared to other approaches in terms of cloud cost, infrastructure cost, we are actually significantly less expensive. So the direct comparison to other approaches, even in the cloud, is a huge potential for savings, plus of course the productivity gains.
I see, yeah, thanks.
Thanks a lot. Still, we have 1 minute. If there are any questions. If no problem, you can reach out to Frank on LinkedIn, or here you can chat with him, or you can see his colleague, Kolya, who has sent a message in the chat box. Please feel free to try Databricks for free, schedule a demo, and learn more about the Lakehouse platform here. So you see the message from him. I'm not sure if I can copy paste it. but I will just resend it again so you have it for sure, all of you. Thanks a lot, Frank.
Very welcome.
Thank
Nice
you
to
so
meet you
much.
all.
Thanks a lot. You can just switch off the camera so that